Hi guys, it's me Sitanga back again with Learn with Sitanga, and today in this video we're going to be looking at a coordinate geometry question from the Edexcel IAL Mathematics P2, and this is from the 2019 June Pure Maths 2 paper. Question number 2. Right, a circle C has equation this, and we are supposed to find the center of the circle and the radius. Alright, whenever they give you the circle equation in this format, what you want to be doing is, so for part A1, what you have to do first is rearrange this into our standard form. So in order to do that, I'm writing the x terms closer together. So I have x squared, I'm then writing 4x, and I have y squared minus 10y and minus 21 equals 0. And then, so what I did was I wrote 4x closer to this and minus 10y closer to this. Now what I have to do is I have to complete the square for the completing square for the x part and do completing square for the y part. This is how you would approach such a question. So here I'd have x plus the number in front of x, which is 4, divided by 2. That gives you an answer of 2. Then you square the bracket. You always put minus regardless of the sign here, and then you take the number inside the bracket 2 and square it. Hope you all remember completing square from IGCSEs. And then you use the same for y thing. So I have plus y minus 10 divided by 2 is minus 5. Then you square this, put a minus outside, take the number inside the bracket and square it. 5 and square it, and then you have minus 21. So this becomes x plus 2 squared minus 4 plus y minus 5 squared minus 25 minus 21 equals 0. X plus 2 squared, and then I'm writing the y part closer to this, and I'm taking all these numbers minus 4, minus 25 and minus 21 to my right hand side. So I'll be left with y minus 5 squared, and on this side I have 4 becomes plus and 25 becomes plus and 21 also becomes plus. So adding this in your calculator, this gives you an answer of 4 plus 25 plus 21, 50. This answer is 50. And I would be left with x plus 2 squared plus y minus 5 squared. Right, for us to figure out the coordinates of the center in part 1, it would simply be the opposite sign of this, so it would be minus 2, and the opposite one of this, which is plus 5. So for part 1, our center would be negative 2 and positive 5. For part 2, there's a radius. So this is our standard circle equation, and in our standard circle equation on the right hand side what we have is a radius squared. So for me to find the radius, what I would do is I would simply find the square root of 50. This gives you an answer of 5 root 2. Now if they ask for the exact answer, I leave it like this, but if they ask for the decimal place value, then I have to get the decimal answer. Maybe like if they ask for around like 3 significant figures or whatever, then you'd find the decimal answer of this. But since here they said just the exact value, I have to leave it like so, like this. Alright guys, part B, they are saying point P, that is 5, 4 lies on C. Find the equation of the tangent to C at P. So now what I would have is I would have now this is my circle. When I have my circle, I have a point P. Let's say this is point P, this is point P. They are saying find the equation of the tangent to the circle at P. So at P, this might be the tangent. It's a straight line. I have to find the equation of this. So what I would do is, now since this is a circle, this is my center, and if I draw a dotted line here, or this line here is the radius line, and as you can see, this radius is perpendicular to this, right? It is perpendicular to our tangent. So we know the relationship between the perpendicular line, the gradient relationship between perpendicular lines. So what I would be doing is I would be finding the gradient of the radius, and then I can find the gradient of my tangent and put it as m, because tangent equation is y equals mx plus c, and m is the gradient. So in order to find gradient of tangent, I would be first finding gradient of radius. So for part B, what I'd have is, now I have this circle. This was my point P. I'd have a straight line at P. Finally, that was a good line. So what I would have is, this is line P now. This is my center C, and the center coordinates are, we found out earlier, it is -2, 5, and P coordinates they gave as 5, 4. 5, 4. And the equation of any line, now the tangent is a straight line, guys, so equation of any straight line we know is in the form y equals mx plus c, and our goal should be to find this particular m value and c, right? So now what I'd be first dealing with is finding this m value, that is a gradient of the tangent. Okay, so to find the gradient of tangent, I'd be first finding the gradient of this particular line. I'd be first finding the gradient of this radius line over here, right? The reason is because this radius line here, this line is perpendicular to my tangent. As you can see, it makes a 90-degree here. It's perpendicular. So if I find the gradient of the radius and get the negative reciprocal, I'd find the radius of the tangent. So I'd be finding the radius of my radius line first. That would be m radius is gradient. That would be y2 minus y1 over x2 minus x1. So I'd be calling this as x1 y1, x2 y2. So x1 y1, x2 y2. So now my y2 is 5 minus, I have 4 over x2 is minus 2, x1 is minus 5. This gives me an answer of 1 over minus 7, or that is minus 1 over 7. This minus 1 over 7 is the gradient of my radius line. So my gradient of the tangent, gradient or m of tangent would be what? Would be the negative reciprocal, or else it would be 7 over 1. I find the reciprocal, I put 7 up and 1 down, and it was minus, so I flip the sign to a plus. So 7 over 1 is simply 7. So this is the gradient of the tangent, and in this case m is 7. So I found my m value as 7. Now what I'm going to do is I'm going to find my c value. So in order to find my c value, which is my y-intercept, what I would be doing is I'd be writing my equation. Now I have y equals mx plus c, and m we found, which was 7x plus c. And we know in order to find c, what I would be doing is I have to substitute a value for y and x, and the values that I substitute are simply the coordinates that line passes through, and we clearly know our tangent passes through this point P, right? So what I would be doing is I would be substituting the y coordinate of P to y here, and x coordinate of P to x here. So doing that, I have y4 and x5, y4 and x5. So instead of y, I'd be putting 4, and instead of x, I'd be putting 5. So what I did was I substituted these values plus c. So now this becomes 4 equals 35 plus c. When I bring 35 to the other side, 4 minus 35 equals c. So 4 minus 35 gives me an answer of minus 31. C equals minus 31. Now I have my m, I have my c. So what would be my final answer, guys? My final answer would be y equals 7x minus 31. This would be my final answer, which is the equation of the tangent to the circle at point P. M is 7, C is minus 31.